to the channel, guys. So this is video number 1 of the Think With Me series. What we'll be doing in this series is we'll be taking random problems, random lead code problems. So whether they are problem of the day or whether they are like contest problems or any other problems, and then we'll be solving them live. So uh, with respect to today's problem of the day, I haven't seen it yet. So I'll be seeing it with you live, and then we'll be looking at what thought process do we need, what intuition do we need in order to solve that particular problem. So we will be solving it live, right? Let's do that. Right, so it's an easy mark problem. What does it say? You're given two strings s1 and s2 of equal length, bank and can, attack and defend, so on and so forth. A string swap is an operation where you choose two indices in a string. It's not necessarily different. Two indices can be the same, can be different, and swap the characters at these indexes. Alright, sure. Return true if it is possible to make both strings equal by performing at most one string swap and exactly one of the strings on exactly one of the strings, otherwise return true. So what does this mean? Bank can, for example, swap the first character with the last character of hash 2. So if I swap the B and K, then this thing becomes bank. And similarly, if I swap the B and K over here, then this becomes can. Attack and defend, not possible. They are already equal, so that means true. Alright, so what I can do is I pick either one of these two strings, and then I can do swapping operation on indices, and what I have to do at the end of the day is make them equal. The very first condition that we can very clearly see is that the characters should be same, right? So there is this condition number 1 obviously is that the total the characters. So if I, for example, have a map which stores character frequency of characters, so I have character over here as the key, and then their frequency as in how many times do they appear, then B, A, and K, and all of them appear one time in both of these strings. So that map, if I create this map for this word and for this word, those two maps should be the same, which you will observe is true in both one and example number 3, but that's not true in example number 2 because there is no A inside of defend, so on and so forth. So that's condition number 1. But then it's not as simple as it looks. I have to take care of other things as well, right? I have to take care of other things such as the positioning of these characters, because if you think about it, B, A, and K, K, A, and B. Now, thing is, I swap these two characters, this becomes bank. Sure. But then, for example, if it was K, if it was something like this, so I, you know, N, B, K, A, would I then, so you see the frequency is still the same of all the characters, but in this scenario, would I be able to make bank out of it? That's the question which I'm asking from myself. So how can I make bank from this? If I swap B and A, sure. uh, so A is at its correct position and then B is at the left, so yeah, I can. So if I swap K and N at this point, so it's going to become this, and then I can swap these two, so it's going to become bang. Then that means this is the only condition which I want. If the characters are the same, if their frequency is the same in both the strings, then that's the only thing which I'm looking for. And like after following a certain series of swaps, I'll be able to make the word no matter what. So I just want to have two maps, one for s1, one for s2. So I'll take a map simply of character comma integer, map 1 and map 2 respectively for string number 1 and string number 2. And what I'll do is just very quickly uh, you know populate it. So for character I in S1, I'll just populate it mp of I plus plus, right? That's how you populate a map, and I'll do the same thing for um, S2 as well. S2 as well. If you don't understand this syntax, if you want me to go into the depth of this syntax, please let me know in the comments. By the way, it's very simple. If you just understand the basics of maps, then you will understand what I've written over here, right? But if it's not clear, let me know in the comments. Alright, so with this, I have both of the maps populated, and I just mp1, mp2, by the way, sorry, mp1 and mp2, and I just want to return if both of them are equal. So if mp1 is equals to mp2 or not. That's it, I think. My internet is not working. Let me make sure that it works. Right, so if I run this code, does it pass the test cases? Um, yeah, so it passes the example test cases. If I submit it, and let's see if it passes the overall test cases, given that the constraints are so small. Oh, it doesn't. It doesn't. It just passes 103 test cases, right? So let's see why is this. We are expecting false. All right, that is exactly what I was afraid of. So you see, the characters are the same, just like we were talking about over here. The characters are the same, but their order is not the same. So like I tried to sort of change the order, but then if still I was able to make the word bank, so I thought it's going to, this approach is going to pass the test cases, but then it doesn't. And this is basically what makes comparative programming so beautiful, right? It's not the problem that is good. It's the magic, the real magic, the real challenge is actually the test cases, right? So TCBA. Now why can't I make ABCD from this? um, I can do as many operations as I want, right? A string swap is an operation where you choose two indices in a string, not necessarily different, and swap the characters at these. By performing at most one if string swap, see, it's very important to read the problem very carefully. You can only at max perform one if string swap on exactly one of them. Doesn't matter which string you choose. At most one swap. For this, you see, even I shouldn't. If it was NBKA, I should have stopped over here, because I needed two swaps, right? First I swapped so this was the word, I swapped DNA, and then I swapped uh, first swap, third, at the third swap I was able to make back. So I should, this test case is going to fail if you're only given at most one string swap, right? So what I need to do is this. If we extend upon this same approach, then I can still have the character and frequency map, but then over here, rather than having an integer, I can have a pair. I can have a pair such that it stores frequency comma index, something like that. So you see BANK, so 0, 1, 2, and 3, and then the other map is going to be again BANK for S2, but then the pair would be, I'm talking about frequency comma index, right? The frequency is 1, obviously that's cool, but then the index of B over here is what? It's 3. For A it's the same, for N it's the same, 2, and for K it's a 0. So you see, only two indexes are differing in position, and this is what I'll have to check. The first thing which I'll check is that there is no compromise on frequency. You see, so for example, if I have 2 or 3 or 4 B's over here and just a single B over here, no matter how many swaps I do, I won't be able to make the word. So there is no compromise there, no compromise on the quantity, the frequency. The next thing which I want to see, if the frequency is the same, all good. But then I want to see that, so I can only allow at max two of the indexes should be different, and I'll just swap them. So over here 0 if different than 3, and 3 is different than 0. These two are the same. So no matter how many characters the word actually has, I can only allow at max two indexes to be different if the frequency is the same, that is, right? So I'll make that change over here. I'll say I don't want an integer over here. I want a pair of int comma int, and then for so I'll have to have a loop over here, something like, you know, I take s1 dot size. Both of them have the same size, right, of equal length. So I'll do something like this: for int I equals 0, I is less than n, I plus plus, and I want to in at the place of that particular character. So at the this is the key s of I, s1 of I actually. S1 of I is actually the key, and the value which I want to put is a pair, which is frequency comma idx. Right. So if it's already present before, I want to update it. If it's already a present before, I want to update it. If it's not, then I want to make it one. If I write mp of s1 of I plus plus, would that make sense? I think so. Yeah. So you see what this is going to do is it's going to take the previous value and it's going to update it by one. No, it doesn't make sense because mp of s1 of I is itself a pair, right? I can say dot first over here, dot first. So I just wanna say whatever the first value is, initially it's going to be 0. Just increment it by 1. The increment the old value by 1, or I can do something like this, you know. Um I can have a condition. So e of s of I. This is the thing which I wanna update. Initially it's going to be 0, right? Initially it's going to be 0, so I can, how much is the frequency? If I see it like this, mp of s of I don't know if it's going to give me, is it going to give me 1 or is it going to give me 0? Not sure. Let's see. Let's see. I just incremented by int frequency and the I index. Basically, what index is it present at? Oh, there is this other problem as well. What if I have a character which is present multiple times in the string, right? So for example, T and T. So what index am I going to store? That is one other problem. Which is, so if I have unique characters, then this approach works. But then if I have multiple characters, then this approach doesn't work. So I'll have to have multiple indexes, right? So what should we do? What should we do in this sort of a scenario? Well, I now realize that I'm making this problem too complicated. I'm actually over engineering it. You know, there could be a very simple, since we've already said that at most two characters can be out of their place, right? Two characters can be out of their place. So we go back to the original version of our code wherein we store the frequencies, so on and so forth. We compare the maps. So the very first thing, in order for us to return true, is that both the maps should be number one equal, right? Both the maps should be equal. This is condition one. Condition two is that I can only make two swaps. So I'll just, you know, compare b a n k and k a n b in o of n, right? I'll see if both of these match or not. These do not match, so I'll have a variable in which I store the unmatched positions. Initially it's 0. Since these do not match, I'll increment it by 1, right? I'll increment my I match, then these do not match, so 2. Now I can have at most two unmatched characters, so that I can swap their indexes, right? So number one condition is this, that the maps should be the same, the character frequency should be the same in both the strings. And number two condition is that the count of unmatched character characters should be only 2. So I'll just have a loop O of n over here for int I0, I n, I plus plus. What I'm gonna do is I'll have, you know, unmatched variable, right? And I just wanna see if s1 of I, if it's not equals to s2 of I, then what you can do is increment unmatched, right? And I just return the first condition again, mp1 equals mp2, and then unmatched should be less than equals to 2, right? I hope this is going to pass all our test cases. I am very confident. N, actually n is not over here. N is equals to s1 dot size. If I take the leap and if I directly submit it without running the test cases, let's see what happens. So yeah, this passes all our test cases. And if we talk about the time and space complexity, let's talk about the time and space complexity for a while, right? The time complexity of this code is going to be none other than O of n. Why? Well, O of n, because you see the size of string number 1 is n, and then the size of string 2 is also n. So you iterate over each of the characters only twice. Number 1, when you're iterating over them in order to calculate the frequency, in order to populate the map, the character frequency map, and then you iterate them again O of n number of iterations over here. So it ultimately, so you see O of n over here, O of n over here, O of n over here. So it's actually O of 3n. You are iterating over the whole array 3 times, but then since this is a linear factor, we can, when we are talking about asymptotic notation, then we can just ignore this 3, right? And if I talk about the space complexity, that's going to be O of n as well, because I'm taking these two character maps, right? I'm taking these two character maps which are storing all of the characters. So at max the size of both of these maps is n. It's not any larger than that, right? So that was our approach. I hope you liked this video, and feel free to share any more optimalities, any more, if you have any method which can make this code more optimal. Maybe I can reduce the space complexity to O of 1. Maybe I have some method in which I can do the job without taking the character frequency maps, right? So let me know in the comments. I hope you liked the video, and I'll see you in the next one.